Good morning guys, welcome to another week of online learning for computer science. The objectives for this week include more Boolean algebra practice, so we'll have a look at the question that I posed last week and go through the answer to that in this particular presentation. I will also give you another past exam question to practice and upload your answer to tomorrow. Also, we're going to move on to our new focus, so we're going to sort of park the GUI based exercises that you've been doing recently, because I feel that you've hopefully begun to get quite a bit of experience of knowledge of working with the Windows Forms applications, and we're going to start looking at something called object orientated programming. So there'll be a project based around that this week. The final thing is just a reminder that this Friday you have to upload your project proposal, and yeah, all the information for that you can find in previous posts, and I think the next slide is just a reminder of that. Okay, so yeah, I think you've heard me sort of talk about and discuss what you've got available to help you do this. Please do ask me questions as well this week. One or two of you have already begun to do that to check whether your idea is suitable or not. That's absolutely fine. Okay, so the Boolean algebra question from last week, let's have a look at it and work through the answer to it. So it was worth 4 marks, and let's have a look at how this mark scheme broke down those 4 marks. Okay, so using the rules of Boolean algebra, simplify the following expression. Now, I would always start, you know, because you can go different routes to get to the right answer using Boolean algebra. So some of you might not necessarily have done it this route but still arrived at the right answer. That's absolutely fine. You must be clear in terms of how you've got to your final answer, and that's the bit that you know, is really worth cross-checking against what you've submitted to make sure you have followed through and demonstrated the right application of the rules to simplify the expression. So if I grab my highlighter, if I'm looking at this particular expression, maybe the 2 obvious bits to begin with where I can apply some simplification rules, if I can get the highlighter, that is, would be this bit here, because that definitely looks like one of my simple rules. And also, if I'm kind of analysing this expression, then this bit here as well. Okay, so you must, and it's a bit arduous, it's a bit painful, but you do need to go through the process of writing out the expression each time after you've applied one of the rules. So in this instance, let's have a look at what the mark scheme says. Okay, so in this particular question, step 2, which I'll just kind of draw on here, this is the resulting expression, and you can see what they've done is that they've applied this rule. So not B or 0 equals not B. So something odd by a 0 is always going to be the term that it was odd by. So in this case, that's not B. So you can see here the updated version of this particular equation is exactly the same, except on this side now we just have the not B sorted. Okay, so stage 1 done. You might have started on the other side. That's where we're going to go next. So next we're going to tackle the next simple rule that we can apply to this expression. So something odd by itself is going to be itself. So if we reveal that, we can see, well, B or B is just going to leave B, and then we have our updated equation written out to show that we've applied that successfully. So number 3 over here, and we can see that we've just got, if I can try and get some consistency, we've just got the B now on this side of the expression. Okay, so all good so far. Now you can see the next step that they've given, and there's always a clue that you're going to need De Morgan's law if you've got some overheading knots across the whole expression, or even part of the expression, because De Morgan's is actually quite a good way to get rid of those overhanging knots. And a good place to apply it in this particular example is going to be to the middle here, because we know that as we work through the process of De Morgan's that we're going to then need to put a knot across the whole expression, and that's going to allow us by doing that to get rid of this particular not and remove it from the entire expression. Okay, so that's quite an important thing to think about when you're applying De Morgan's law, as long as you're following the rules of where you apply it. So if we apply it in this particular instance, again showing the working and moving to the next step. So if we move from here and apply this particular one to part 4, and if I reveal that, you can see we've converted the and to an or, and then we've done our overhead bars, which they've not written out and visualized on here, and then they've cancelled the double negation, and that is the result, okay, for step number 4. So far we've got 1 mark, 2 mark, we've applied De Morgan's 3 marks. So the question is, where is the 4th mark? And actually in this example, and I think quite a few of you, and this is a good lesson learned, and this is just practicing a little bit of experience, but actually if you look carefully at this expression, that is actually equal, is actually the Boolean logic for one of our logic gates. So it means that rather than having all of these 3 different gates that we got at the minute, 2 ands and an or, we can actually simplify that further. And well done to those of you that are spotted. And remember this future reference, because AQA do like to simplify expressions to this and expect you to just identify that that is the actual, if I can get my animations on, and I'll erase that not very well positioned annotation there. It's the XOR gate. Okay, it's the XOR gate that you actually got, so you can simplify that down further, and that's where your final mark was in this particular question. So watch out for that pattern, enabling you to simplify it slightly further and recognize that that is the logic for the XOR gate. Okay, so that was the Boolean algebra question from last week. Hopefully it's helpful just going through it each time. And yeah, I would say with the De Morgan's law, you know, just have a go at practicing working your way through those steps, and you'll see how that expression becomes that expression if you follow through the rules of application there. Okay, this is today's Boolean algebra question, so this is going to be due for submission by tomorrow, and I'll go through it later this week. So hopefully you've got a fairly straightforward question at the start here with the lozenges, and so if you just label these A, B, C, D, E, etc., and then you can submit your answer in that form perhaps, or come up with some logic to do that. And in terms of the actual equation to simplify, also the expression to simplify, it's here of course. The only hint I would give here is that it uses, I think the first part of this expression is fairly straightforward. You will need to use one of the, I guess, less frequently used rules that we covered in lesson 2 on Boolean algebra to help you do this, but I'm not going to give you more of a hint than that really. If you've been practicing, hopefully you'll recognise where there's opportunities to apply this particular rule. Okay, so that's to practice today and submit tomorrow. It's short and sweet, but just keeps it refreshed in your mind. And then the final thing, of course, that you need to be aware of is how do you actually go about getting up and running with the object-oriented programming stuff. Well, for that, you've got a link to an online course which is going to guide you through the basics. I've been working through the course myself last week. I think in terms of the amount of time, it equates to about 4 lessons plus maybe a little bit of additional time for homework, so maybe about 5 hours worth of work. So if you spread that across the course of the week, it should actually sort of substitute for our lessons quite nicely. Why am I getting you to focus on object-oriented programming? Well, I mean, some key reasons really. One is that it's an example of a programming paradigm. So if you remember the programming paradigms that we've been covering so far, we've mainly been focused on doing procedural programming, but we have touched on a little bit of an assembly language this year as well. But procedural is the dominant paradigm that we've been using to create solutions to problems. Well, OO is a very different style of programming, and it's a different way of actually creating programs to solve problems, and it has a lot of benefits, and it's probably the most widely used paradigm in the industry. Okay, but it does take time to get your head round, and it's a key concept of the year 2 course. It's also a key concept in the project, and I've just highlighted here in this box just to evidence that particular fact. Okay, so this is taken from the the marking grid for the year 2 project, and it's the marking grid for the skills in the program that you create. And if you remember, those skills are categorized by their difficulty. So you've got category A skills, which you might say are the hardest, and then category B, and there are category C skills. Well, if you look in this particular skill set that AQA outline, you can see that down here in category B, oops, I've highlighted too much there, but using simple object orientated program models is a category B skill. Okay, so it is a higher level skill. You can see up in category A, using complex OO programming and features like inheritance, competition, and so on, they would enable you to score even higher marks. Okay, now you're not actually going to get to the point where you're doing inheritance and composition and so on in these tutorials. I would say that this tutorial course is pitched more at the simple OO stuff, but it's a good introduction, and it's a good way for you to begin to get your head around some of the key concepts and key differences of working using this particular paradigm. I would advise that you do take notes as you're working your way through the theory videos, but the theory videos also allow you to actually program as well, and 100% definitely program along with him. So the exercises that he's demonstrating, you actually create and program as you're working your way through. Okay, and do experiment and do play around with it. Hopefully it's going to be quite eye-opening in some places. You maybe might begin to latch on this idea that actually working with objects is something that you've been doing already, just without realizing it and understanding the theory behind it. But see if you can sort of latch onto that idea as well. But there's so many useful skills and ideas in these tutorials, and I think they're quite well explained. But definitely work along with him. And you know, if you are a note taker, if you think that helps you, then I would definitely recommend you to make some notes as well, because we will come back to this in year 2. It is on the actual exam as well as the project, so you do need to be well versed in OO. Okay, so that's the key thing. In terms of evidence, well, once you've completed the first half of the course, you'll see that the second half of the course then works on a project where you can then apply the skills that you've actually acquired in the first half, and that's in the form of this sort of warrior battle simulation. Okay, so that's going to be a full-on program, and that's the piece of evidence that I want you to submit to me come the end of this week. So come Friday, you should be able to upload a video walkthrough of this particular program, which demonstrates that you've been able to create, a relatively simple object-oriented program, but nevertheless it's a starting point on which we can then build and develop your understanding further this week. Okay, so yeah, I'll post the link in the post section, and that's the key thing to be working on this week, along with the odd Boolean algebra question that we'll be posting on. And finally, just make sure, again, final reminder, you've got that project proposal ready to submit.